Hello, good afternoon everyone. I am Ringo Goel. Today we are going to discuss about JPG compression. So first we look into what is JPG and what is its standard. JPG is an image compression standard which was accepted as an international standard in 1992, developed by the Joint Photographic Expert Group of the ISO and IEC for coding and compression of color, gray and scale images yields acceptable compression in 10:1 range. JPG is a loosely compression technique based on the DCT. JPG is a general image compression technique independent of the image resolution, image and pixel aspect ratio, color system, image complexity. A scheme for video compression based on JPG called Motion JPG, which is so called MJPEG, exists. JPG is effective because of the following the observations. The three observations. Image data usually changes slowly across an image, especially without an 8 by 8 block. Therefore, image contain much redundancy. Experiments indicate that humans are not very sensitive to the high frequency data images. Therefore, we can remove much of this data using transform coding. Humans are much more sensitive to brightness, luminance, information than to color. JPG uses chroma subsampling, which is 4:2:0. The following slide gives an overview of the various steps in JPG compression. So this is the overall view image, the block diagram of the JPG encoding, where the DCT, quantization, quantizing tables and coding tables which are so involved, and the header tables data, the entropy coding which is done thus to process the coding tables, DPCM and RLC. So this is the overall JPG encoding overview of JPG standard. The main step in JPG encoding are the following: transform RGB to YUV or YIQ and subsample color, DCT on 8 by 8 image blocks, quantization, zigzag ordering and run length encoding, entropy coding, which are the main steps in JPG encoding. So DCT on image blocks. So DCT on image blocks, which the image is divided into 8 by 8 block, whereas 2D DCT is performed on each block. The DCT is performed independently for each block. This is why when a high degree of compression is requested, JPG gives an blocky image result. Quantization. Quantization in JPG aims to reducing the total number of bits in the compressed image. Divide each entry in the frequency space block by an integer between 1 and 255. Then the round which continues. Use a quantizing matrix QUV, which is FUV round, which holds FUV by QUV. So this is the luminance quantization tables and the chrominance quantization tables in according to quantization. Multiple quantization matrices can be used, perhaps by scaling the defaults, allowing the user to choose how much compression to use. Traits of quality versus compression ratio. More compression means larger entries in queue. An example of JPG encoding and decoding on one image block is shown in the next slide. Preparation for entropy coding. We have seen two main steps in JPG coding, which is DCT and quantization. The remaining steps all lead up to the entropy coding of the quantized DCT coefficients. These additional data compression steps are lossless. Much of the loosiness is in the quantization step. Now we look into the run length coding of the JPG. We now do run length coding. AC and DC components are treated directly, since after the quantization we have many of zero AC components. RLC is a good idea with respect to AC components. Note that most of the zero components are towards the lower right corner. lower right corner, high spatial frequencies. To take advantage of this, use zigzag scanning to correct x64 vector run length coding. Now, what is zigzag scanning in JPG? This is done so that the coefficients are in order of increasing frequency. The higher frequency coefficients are more likely to be 0 after quantization. This improves the compression of run length encoding. Do run length encoding and Huffman coding in this zigzag scan. Thank you very much. This is the overall view of JPG and the number of models which thus involved in this JPG. Thank you very much. The presentation is presented by Rinku Goyal. Thank you.